All right, Kepler's laws, part two. The video messed up, so here we go. I'm gonna try to get this finished for you. All right, so on this problem, what you're doing, we showed you, we put in the period of Io, the period of Callisto. Like I said, because they're both in the same unit, day and day, you don't need to change them into seconds. Okay, period is usually in seconds, but in this equation, you can just put, as long as they agree, day, day, hour, hour, well, month, month, year, year, it's fine. Okay, I don't think anything goes around in 1 hour, but oh well. Okay, now, Io, we said, is 4.2 units away from Jupiter. So, I mean, I didn't really draw the diagram here, but oh well, it wouldn't be right. But Io will be 4.2, and then we'll find out, well, how far is Callisto? Okay, so what you do for the math here, 1.8 divided by 16.7 is 0.107, 108. 0.108, you got to square that number, will equal 4.2 cubed over R. So 4.2 times 4.2 times 4.2 is 74.1 over R cubed. So look at what I'm going to have to do here. R cubed times 0.108 squared. All right, so it's going to be 0.0117 R cubed equals 74.1. So now divide both sides by 0.0117, and then get the cube root. So 74.1 divided by 0.0117 is 6333. Now, to get the cube root, what you do, some calculators have a button, it's R cubed is equal to that. So the cube root that looks like that. But you might not have that button, and I don't either. So instead, what you can do is take 6333 and you raise it to the 1/3 power. Now, 1/3 is the same as 1 divided by 3, which is 0.333333. So if I raise 6333 to the 1 divided by 3 power, 0.3333 power, I'll get the cube root. And on my calculator, what I do is this. Okay, so I got to put, there's a button called X to the Y. Look at my chalked up calculator here. X to the Y. I'm going to put in the number 63333, or 6333. Okay, now X to the Y, and I'm going to put in X to the Y. I push the X to the Y button, 0.3333. Raise it to that power, and it is 18.5. So the radius is 18.5 units. So what that means is Io is like 4 Jupiter. If you count Jupiter, Io is like 4 Jupiters away. That might be correct for Io. Okay, like I drew. But then Callisto will be 18 Jupiters. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Callisto might be this far away from Jupiter, if that's where Jupiter is. So it's incredible. 18 Jupiter diameters away. Okay. Now, here's one more little thing they added on just for the math. It says, if the diameter of Jupiter is about 1.43 10 to the 8, calculate the mean distance between Jupiter and Callisto in meters. So this is just a conversion. And if you have 18.5 Jupiter units, I'll call that Jupiter units because it's only true for Galileo for Jupiter. If you have 18.5, what he's saying is 1 Jupiter unit, which is the diameter, is equal to 1.43 10 to the 8 meters. This is a really cool thing about Galileo and Newton as well. Like, they didn't know how many meters away the moon was from the planet or anything like that. They didn't know that, but they did have a formula set. Once we figured out what the actual diameter of Jupiter was, today, now we go to their math, and they were right. We see it makes sense. So 18.5 times 1.43 exponential 8. So now we're getting back to scientific notation that we saw earlier in the year. and it's 2.64 times 10 to the, wow, 1, 2, 3, 4, 5, 6, 7, 8, looks like to the 9th power. Yeah, make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 2.64 times 10 to the 9th meters is the distance there. That was part 2, part 2. Okay. And here's another one really good. Okay, another good question. All right. It says, how far above Jupiter's surface is Callisto? How far above Jupiter's surface is Callisto? For this, I like to draw a little diagram. Let's say if this is Jupiter, and remember, from the center of Jupiter to the center of Callisto, that distance, that orbital distance, is 2.64 10 to the 9th meters. But on the other hand, what is the diameter of Jupiter? We saw that. We said it was given to you. The diameter is 1.43 10 to the 8th. So we know the diameter is from one side to the other is 1.43 10 to the 8th. So what's the radius of Jupiter? Let's figure that out. Why do we need that? Because the radius of Jupiter, I want to get a different chalk color and I didn't. If this is the diameter of Jupiter, 1.43 10 to the 8th, divided by 2, and that will give me the radius. So 1.43 10 to the 8th divided by 2 is 7 point, or how about we'll say 0.715 times 10 to the 8th. Yeah, that works out. 0.715 10 to the 8th. Or, well, it doesn't matter. Maybe you want 7.15 10 to the 7th. But that's the radius. The radius of Jupiter is half the diameter. So it's going to be, I'll just put it 7.15 10 to the 7th. If you put that in your calculator, 1.43 10 to the 8th divided by 2, you're going to get 7.15 10 to the 8th. 10 to the 7th. Sorry, 10 to the 7th. 7.15 10 to the 7th. I'll have to do it on my own by looking at the numbers. So now, how far above the surface is Callisto? Well, that's going to be 2.64 10 to the 9th meters minus the radius of Jupiter minus 7.15 10 to the 7th. I'll show you what you can do if you want to be really good with your sig figs, but you don't have to. You can rewrite this as 0.00. Wait, it'll be 0.0071. It doesn't matter. 00715 10 to the 9th, right? Yeah. 0.00715 10 to the 9th will be the same as that number. You don't have to do this if you don't want to, because then you take 2.64 minus 00715 to get your sig figs right. But don't even worry about that. Just subtract that from that. So 2.64 10 to the 9th divided by, minus 7.15 exponential 7 is 2.57 times 10 to the 9th. So it went down a little bit. 6, 7, 8, 9. Yeah, 2.57 10 to the 9th meters. So that would tell you that from here to the surface. You know, now technically we're not counting Callisto's little radius and subtract it, but it's so small compared to Jupiter, we can ignore that part. So just this part right here. All right, and looks like there's one more question. And it says, all right, let's see. I'll do the one about Mars. It might be that we're going to spend more than one day. There's another worksheet. I'm asking you to do the first worksheet on the first day, but I might have you do the next page on the next day. So this will just take care of a lot of things. Mars has an orbital radius around the sun 1.53 times that of the Earth orbital radius. Okay, so let's do this. Let's put Mars is here. And let's put the Earth here. Let's put the sun right there. Well, I should put them in the middle. Even though it's not a perfect circle, you can treat them like a circle. So from Earth to the sun, we'll call that x. And from Mars to the sun, we'll say is 1.53x. Okay, so Earth to the sun, x radius, and Mars to the sun, 1.53x. Maybe it makes more sense in the equation if I do it this way. The period of Mars divided by the period of Earth squared will be the radius of Mars divided by the radius of Earth cubed. So the radius of Mars, we're going to say is 1.53x. And the Earth will be x. Now we don't even need the numbers because the x's are going to cancel out. You can see that. So we don't even need that x or that x. It's going to be 1.53 over 1. For Mars, it says, predict the period of Mars to orbit the sun in Earth days. Orbit the sun. Okay, how many days would it take for Mars to go around the sun in Earth days? Well, we're going to put in the period of Earth in days is 365 days. So, what will it be in Mars? All right, and you got to square it right there. Okay, so here we go. There's more algebra stuff going on. So 1.53 cubed. I think the math here is going to be a little bit easier than the other problem. 3.58 equals t squared over 365 squared, which is 133,225. I'll just put all the numbers and I'll get 366 in the end because that has 3. Now I got to multiply these two numbers. T squared will equal 3.58 times 133,225, which is now 476,945.5. It looks like now. I'll just stop with 5. Then get the square root of that and the square root of that, and it looks like 691 days. So that makes sense. Mars is farther away from the Earth. Farther away from the sun than the Earth is. So it takes 691 Earth days, because we use 365 Earth days. It takes 691 days for Mars to take one complete orbit around the sun. So think about that. That's almost twice. Not quite. Well, it's close to twice, but not quite twice of what the Earth takes. Us 1 year, so it almost takes 2 years to go around. 691 divided by 365. It takes 1.9 years for Mars to go around. Okay, so work that one sheet, and then probably I'll see you in class, and I'll explain and go over some of these, and then we'll have you do some more problems like it. So this will probably be more than 1 day lesson. I'll see you.